Morning, everyone. Welcome to this presentation on the ppwr sustainable solution. My name is Alessandro Monopoli. I'm a product manager at Marchesini Group, and I'm a member of the Marchesini Sustainable Team, a cross-function team that works among our several divisions to find, study, and implement sustainable solutions in line with the new regulation ppwr. Today's presentation, it will be divided in two parts. We begin with a quick overview of the ppwr. I promise nothing too academic, just to highlight the key points. Then we will move to much more interesting things, so solutions that are already available on the market and how they can fit inside automatic packaging machine. So let's begin with the ppwr regulation. It's the acronym of the Packaging Waste Regulation, the new regulation published from the European Union in 22nd January 2025, designed to reduce the packaging waste by promoting the transition to a circular economy, establishing a specific target on packaging and packaging waste. There are two things that I would like to point out on this slide. The first is that we have now a regulation, no longer a directive. It means that it's much stronger because it's directly applicable without any additional implementation from each state. And the second thing is that you can see it's official, so there is no way back. It applies to all packaging regardless the use of the origin, but of course it will be subjected to the other EU regulation related to the safety, hygiene and protection of the product packed. The general targets are to revise and reinforce the extended producer responsibility framework with a strong focus on waste prevention, following the three R rules, reduce, reuse and recycle. In addition, it introduced specific obligation in terms of waste management, in particular on collection, treatment and recycle of packaging waste. Many of these topics were already present in the previous directive, so why was the ppwr introduced? Well, the answer lies in the needs for the European Union to harmonize national measurement, creating a common regulatory framework that establish clear and shared obligation across all EU members, because now, as we saw before, directive asks you to introduce in each state different legislation. And this, of course, will support the transition because it's the main goal to the circular economy. Obligation, target, limits span over different topics, such as extended producer responsibility. We have environment labeling, recyclability, reuse and refill, compostability, PFAS, many things. Of course, as you can imagine, we don't have time to go inside to each one of them. We just focus on the main aspect. But before going in this detail, a clarification is needed because the ppwr is incomplete. Unfortunately, yes, because we perfectly know where we are going. We know by when we must be there. But what we don't yet know is how to get there, because it's still missing the calculation method that will help and will guide the producer to redesign and assess the packaging in line with the ppwr. So the 3 years period, 2026 to 2029, would be fundamental because EU will release Implementation Act and Delegated Act that will complete finally the ppwr regulation. So we start with the first obligation. Packaging and overpackaging minimization is addressed in the Chapter 2, Article 10. It states that by 2030, packaging must be designed in order to minimize both volume and weight, while maintaining, of course, its essential function of protection, hygiene, and safety. This is fundamental because even if we don't know exactly the method calculation, we perfectly know that a situation like that, where to produce a blister with 2 tablets, we are consuming the material for 10, so it will be not permitted anymore. Okay, the regulation tries to optimize and avoid wasting in this sense. Related to the packaging minimization, we also have another important articles in the chapter 5. So related to the multi-packaging, by 2030, packaging must be designed in order to ensure that empty space for group packaging, e-commerce and transport packaging will not exceed the 50% of the whole volume. Again, we don't have the calculation method, but the orientation of this article is to avoid situation like maybe you have already experienced it, like you have box almost empty, just filled with paper or bubble empty, that it will not useful for nothing. Okay. Another important change introduced by the new regulation is related to the labeling system. So by 2028, all packages must be marked with a standardized pictogram, which include information about the composition of the packaging, as long as information that help end consumer to correctly sort the waste, the packaging when it becomes waste. Same pictogram we will display on the waste bin, so the idea is to make recyclability easier as much as possible, and in addition it will display information like EPR information through a QR code, information related to the return and reuse if the packaging allow this, and also compostability, presence of hazardous substance, as well as percentage of recycled content. We are now moving to one of the core, the main topics in this new regulation, recyclability. By 2030, packaging introduced on the market must be recyclable. Recyclable in these terms means that can be effectively collect, sort, and recycle at scale to produce a secondary raw material with high quality comparable to the original one. By 2028, European Union will release a design for criteria. According to this design for recycle criteria, according to this criteria, each producer must assess the recyclability performance of their packaging in different grades, A, B, C. Grade A refers to packaging that is over 95% recyclable, grade B 80% recyclable, grade C 70% recyclable. From 2030, it will be allowed on the market only packaging that is at least 70% recyclable. From 2038, limit will be raised, and 80% it will be the minimum level of packaging that can be placed. This will be important because according to this, as we see later, it will be calculated the fees that any producer need to pay, okay, for the waste management of the packaging. Connected to the recyclability, we have also another important aspect, the recycled content. So packaging by 2030 not only must be recyclable, but it also contain a percentage of recycled content coming from the post-consumer plastic waste. So European Union set the target from 2030, as you were seeing in the slide, raising from 2040. We have the division in 4 different categories: pet food grade packaging excluding bottle, then we have the food grade packaging other plastic bottle for single-use drinks, and other packaging in not food plastic. By 2028, European Union will release delegated acts that will confirm this percentage according to the capability of the recycled streaming to provide with the necessary, post-consumer plastic waste, because everything is under development, as you can imagine. Before we're now approaching the end of the ppwr overview, but before going in the detail of technical solution, just a few words about how APR has evolved with the new regulation. 2 major changements. The first one is that now producer must be registered in each country where they produce, where they place the packaging, so they are clearly identified. And the second thing is that ppwr introduce eco-modulated fees. Up to now, producers are responsible for the packaging placed on the market. They have to cover for the waste management in terms of recycle, treatment, and collection. From 2030, quantity will no longer be the only variable, but fees will be adjusted according to the environmental performance of the packaging. It means 1 ton of plastic can cost less or more depending on grade, depending on the percentage of recycled content, depending on how much we are capable to reduce the packaging. So the well design leads less cost. We now go to the transition to the sustainable packaging. We saw how much the regulation push for packaging that is more and more recyclable, okay, and packaging that will not affect the collection and the sorting one is became waste. Obvious solution, natural solution is the monomaterial. So packaging that is made of the same material in order that we don't are obliged to separate anything and we are not compromise the recycle streaming. We're going to see 3 different examples of packaging, and for each one of them we will focus on solutions that are present on the market in terms of monomaterial and how they can be implemented inside automatic packaging machine. So we have blister, trace, and stick pack. We begin with blister. I think that you already know this kind of pack. Current situation is that we have material made of different material. Bottom part usually plastic, leading material usually aluminium. Impossible to recycle because we cannot separate in any way. Solution are the monomaterial. There is a topic related to the barrier that we will see later, but there are solutions so to solve it. Now in the market are present 5 different solutions. We have a PET monomaterial, the bottle one. The RP material is PET plus a part of recycled content inside, normally like a sandwich, so you have virgin material at the side, external side, the recycled content in the middle. We have the polypropylene, not new one, but has been is coming back more and more thanks to the new regulation. New entry, high density polyethylene, that we will see it will be guaranteed the better barrier among this one, and PVC free aluminium. So aluminium is a multi-material, OPA, aluminium, and up to now PVC. Suppliers are replacing the PVC part with a more sustainable material as PA or PP. In this case, this kind of product can be recycled like the Coca-Cola can, so in the same way. Each of this material has a specific property, specific barrier, specific characteristic. There is no better material than the other. It's a balance, as always, between the cost that you are willing to pay and the level of protection that you are looking for. We just go through this material with some pros and cons description. We start with PET, so direct drop-in. We can use mainly the same format tools of PVC, for example. Easy to form, easy to seal. On the other side, a really low barrier against moisture and a quite tricky push-through situation. Our PET is mainly the same, just with some additional restriction for farm application, not your case. HDP is the new entry, is quite interesting because it's the material that so far guaranteed the better protection, like they claim like PVC, PE, PVDC 90 grams, really good push through. On the other side, dedicated tools are needed, so we cannot reuse the same of the PVC or PVDC or the clear one. Sometimes plug assist, and the recycle stream is still in development. Polypropylene, again, is not new, but has been definitely improved compared to the past. So it's at the level of barrier is a little bit below the high density polyethylene. Push through is really good. The recycle stream is already set, but as a cons, we have quite high shrink, and the plug assist are definitely mandatory to form the cavities. We end up with aluminium, perfect protection against oxygen and moisture, direct drop-in. We can use the same tools. Big cons: increase the package dimension, high cost. So again, it's a balance as always. We are now looking how this material can fit inside a blister machine. We start with the forming focus. We say that most of them require plug assist, so we need to include inside the machine. The standard material can work mainly with hair. In this case, it's not possible. Motorization and complexity, it will be a little bit increased. And another important thing, this material tend to stick to the mold. So like in this case, we are seeing the gold part is a special treatment to avoid the sticking on the forming. Sealing is another quite tricky point because many of these materials are sensitive to it, so we need to treat in a really gentle way. It's preferable to go to sealing solution that works with low temperature while maintaining a longer contact time, longer contact surface between the heating element and the material. The goal is to stress as less as possible the sealing activity in order to make it better as possible, of course. The third focus is related to the indexing. It's a reality. New materials are less stable compared to PVC or compared to other standard traditional one. So capability of the machine to synchronize and correct the position of the machine of the material inside the machine will be fundamental through a different station like the feeding system, the sealing system, and the cutting system. So just as an example of the sealing system, the idea is to detect, thanks to the camera, the position of the web and automatically synchronize the lower sealing plate with the forming material, compensating for any possible variation related to the shrink of the material. This way we can make the sealing effective, stable, smooth. We can avoid crashing and loss of efficiency. The same it will be for feeding and cutting with different purpose. The first is feeding, the third one is cutting the blister, okay? We are now going to the trace, the second packaging. So the situation is a little less complex because we don't have the big theme of the barrier, but is still present a situation where you have leading material and a foreign material made of different materials, so impossible to recycle. We can switch to a mono material. In this case, we can find again some material that we have seen before, like PET, recycled PET, polypropylene, and PVC aluminum free, plus two newcomers, PLA and paper tray. Since the behavior of this material are basically the same consideration that as those we have seen for the blister, I focus just on the new material. The first one is a PLA, is bio-based plastic material. So the big process that is compostable, can be thrown in the food waste. Quite easy to implement in the machine, so easy to form, easy to sealing. As a cons, really low barrier, not really useful for the process of sterilization. The other one, paper. We switch completely from plastic to paper, to another material. For sure, we have millions of suppliers, so the source of this kind of application is not a problem. And the recycle, at least here in Europe, is quite well developed. As cons, for sure, we have less rigidity depending on the design, but compared to plastic can be. Bigger volume package and high cost in terms of storage and management. Again, there is no a better solution depending on what you are looking for and where you are placed. Europe is one thing. Maybe if you move to countries that are less, ready to the recycle, and so you can create more pollution. Paper can be an alternative to avoid, you know, to create more pollution than the one that is present in the country. Let's say in this way. So since plastic, it will be more or less same between trays and blister. I would like just to focus on paper tray application. So I just take an example to refresh a little bit how it works. So unlike the blister, we don't have to seal, form, to print, to form and to seal, but paper came already done. So we have to take, square, and then insert with the product. Thanks to different application, can be robot, can be something different. Okay, so it's suitable for many products like we are seeing in the picture, so ampoules, vials, cartridges, syringes plus needles, whatever you want. There is no big limitation. Is made of paper, so recyclable, so compliant with the ppwr. And will finish? Of course not, because as we've seen before, ppwr asks a complete redesign of the packaging, including packaging dimension, packaging volume, in order to minimize this. So based on this perspective, we have we have developed a new paper tray solution that can allow a reduction of paper and glue by up to 50–80% of paper and 50% of glue, while maintaining the availability for, as we are seeing in animation, different products. So there is not a limitation because we use less material. The challenging, of course, it will be make it available for you know, the packaging machine that are already present on the market. We cannot ask you know, to completely redesign the packaging, the automation process. But as we can see for this example, system works pretty well. So we are able to pick, square, feed with different product, and transport to cartouring machine or whatever, even though we are designing the new paper tray with less material and less glue. This is a really important things. So we are just approaching the last of our product, the stick. Current situation, we have a stick made of different material, PET, aluminium, and PE. So aluminium to create the barrier, PE for the sealing, and PET for the forming. Of course, in this way, the material cannot, the packaging cannot be recycled. We have solution. Maybe in this case, not so many as tray and blister, just two, polypropylene and paper. For polypropylene is the, you know, obvious choice if you are looking for a barrier, because as you can imagine, paper cannot provide a big level of protection. Recycle stream is already set, so we have the same consideration that we commented before for tray and blister. On the cons, shrinking and sealing can be a little bit tricky. In addition, we also have a situation related to the tear and notch that it sometimes can be less effective because due to orientation of the fiber of polypropylene. So we are still working on that way. Paper, on the contrary, can be used, but because it's easy to seal, easy to print, can be stuck, so no material shrinkage. So it's okay from this point of view, but on the contrary, barrier is not you know, the big strength of this material. And also we can have a presence, a situation related to the wrinkle and the dust during the cutting. So from application point of view, there are two major focus that I would like to point out. The first one is in the indexing control. We say that this kind of material are a little bit unstable, so we need to control. The machine need to be equipped with indexing control that can adjust and compensate for this kind of stretching and shrinking. And the second thing is related to the sealing, because we need to make the machine capable to adjust the strength, the force according to the material, as well as to set different temperature if needed for all the channel, because removing the PE, for example, with the polypropylene, the sealing, it will be, you know, the most critical point. So I'm perfect. We have just 5 minutes then for the question. We just close our presentation with this message. So we are ready, but most of all, ppwr is not something in the future, so future application, but is something official, present right now. We know that behind, we see that behind obligation there are many possibilities in terms of cost reduction and innovation of the product. Solutions are available, because we see 3, but we miss, for example, the strip and the sachet that can be considered inside, you know, this kind of portfolio. But we saw that solutions are available on the market with different grade of protection. So we don't need to be afraid of the lack of protection. So it's just up to you to lead this transformation, or in the end to be forced to follow. Thank you very much. And if you have any question, I'm here.